Okay, so today we're going to be talking about the post lab for the Hovercraft. So the purpose of this lab was to graphically and mathematically model the relationship between position and time for a moving system in which the forces acting on that system are balanced. In this case, we are doing a video analysis for me riding a hovercraft. Now, the reason it had to be a hovercraft was because we wanted to make sure that the object was moving while also simplifying the amount of forces acting on it. So the only way we could really do this was to find a way to get rid of the force of friction acting on the system. So in this case, our system is going to be defined as me and the hovercraft. So there's a system boundary drawing our dotted line. And after we do a force diagram, we realize that the forces acting on the system are balanced. And here we have the video we analyzed in class. And here is the analysis where we've taken the data points and we plotted and tracked the position of my head over the course of about half the video. And let's take a look at the position versus time graph that this created. So here we notice that we've created a linear graph where we've got a straight line here, and also notice that there's kind of a x-intercept here, but that's only because I don't really appear in the video until about 7-8 seconds. So there's no need to worry about that. We're mostly concerned with this shape here and the fact that it doesn't show any type of upwards opening curve or sideways opening curve. That implies, the straightness of this line implies that I'm moving forward in the positive direction with a constant velocity. So based on our pre-lab discussion about the forces acting on me in the hovercraft, we can see that if the forces acting on a system are balanced, then that means the system has to be moving with a constant velocity. And here we need to be careful because there's a big misconception here. Often people think that if an object is moving in a certain direction, in this case right, that means there has to be a force pushing or pulling it in that direction. Here we find that that's simply not the case. So let's check if this is true for resting objects also. So before the push, we're taking a look at the force diagram that would have been created if we were to use, again, me and the hovercraft as a system. This time the main difference is that the objects are at rest. And taking a look at our forces, we see that we still have the same normal force pushing upwards on the hovercraft by the air. And then we also have a force of gravity acting on both me and the hovercraft by the earth. And these are also balanced because I'm neither moving or being accelerated up or down. So that means the system has a constant velocity as well before being pushed. And again, just for completion, we want to compare with after the push. We decided that the forces were also balanced. And yes, from the lab, we find that in this case, I was moving with a constant velocity in the positive direction. But now we're concerned with what happened in between. What happened between me being at rest and me moving forward with a constant velocity after being pushed? it turns out that during the push, my force diagram changes a little bit. Here's our picture of me during the push, and there's a new force here. So in addition to the normal force pushing up on the hovercraft and the force of gravity pulling me and the hovercraft down, there's also an extra force pushing me to the right, but done by Mr. Scheffler off camera. And here we see that the forces are unbalanced. They're unbalanced because, yes, it's true that in the vertical direction or in the y direction, the forces are balanced. But the fact is, if we take a look at the horizontal direction, in the x direction, there's only one force acting in the x direction or the horizontal direction, and there's nothing balancing out that force. So what we do know is that the forces are unbalanced, and before I had a velocity of 0, and after I had a non-zero velocity because I was moving forward. If this is true, then that means I had to be accelerating, which means my velocity was just changing. So here's our conclusion. We can draw two conclusions from this lab. And we don't really have an equation to show for this, but we have two very important ideas. The first one being that if the forces acting on a system are balanced, then the system is moving with a constant velocity. And secondly, if the forces acting on a system are unbalanced, then the system has to be accelerating. We'll talk more about this later in class.